I'm here to talk about sustainability. Has anybody here ever been asked to evaluate either something they're working on, a project, and say, what are the sustainability goals? What are we able to achieve with this? It's a word that keeps popping up, and not everybody understands exactly what that means. So I'm going to take an approach, try to give you some ways that we think about it, because we work at Ecolab. We work with a lot of customers that have sustainability goals. One of the things we do at Ecolab is we try to achieve our customers' goals when we're trying to implement solutions. So understanding what they mean by sustainability is a very important feature when we're trying to make a suggestion. So I will approach this here first. Let's talk about sustainability. What does sustainability mean? How could we interpret it? A lot of people might think it's some sort of buzzword. I'm trying to just get into some of the basics. I don't want to go on any particular trends, but what really is behind sustainability? Why is it a good idea? Maybe you're already doing it. But then once we understand that, or we get on a page about sustainability, how do we go about improving through sanitary design? That's a great way to improve sustainability. I'll point out how those two things are kind of linked. A lot of times I use the words food safety in here, but I think food safety improvements and sanitary design improvements go hand in hand. When you improve one, you're improving the other a lot of times. And then I'll give you some examples because I really like pictures. I think pictures can really describe a lot for us, so I do include a number of pictures. Don't worry, I was assured everybody can get a copy of all of these things, so some of the pictures I'm not going to go into detail, but please go on the website, download the presentation. You'll have all of it so you can spend time looking at it. So the definition, this is one that I really kind of liked. Looked at a lot of different definitions. People have gone over and tried to define this. This is an older definition, but it's really talking about sustainability as meeting the needs of the present without compromising our ability of future generations to meet their own needs. So thinking about people that are going to come after you. So whatever we're doing now, we're not sacrificing someone else's future. That's a pretty broad definition, but I find it very useful when I'm trying to identify whether or not I'm making a change or a design that improves sustainability. So focus, though, a lot of different focus areas. When you think or you're having conversations about sustainability, there's a lot of people focused on one or maybe more of these. So you got to have a conversation to try to figure out what do they mean by sustainability. Is it environmental? Maybe they have some sort of environmental awareness. There's a consciousness. That is becoming more and more prevalent. People are not wanting to release certain things in the environment. For an industry, or my company produces a lot of chemistry, we have to be really cognizant. We have to watch what is actually being released into the environment. Does it break down naturally? Is there something else that it could impact? Other reasons for sustainability might be climate change. They don't want to impact their climate. They're worried about increases or just some sort of change. It could be their microclimate, their immediate area, or it could be the whole world that they're worried about. Water availability. Have some people come across that I'm worried about having enough clean, fresh water in the future. So if that's a concern, we got to start to understand these concepts of all of this is sustainability. So when you're trying to implement a design that incorporates sustainability, what are you really talking about? Cost of energy, how much energy is? Are we going to get to a point where you can't afford to operate a certain way because energy is just too expensive? And so we have to compromise, ideally not compromising food safety, but these are all sustainability concerns. The size of the usage in industrial, always a target industry. When you think about how much we produce from an industrial application, when you have a big factory, it's going to be a target for anybody worried about sustainability because of the volume. I've been in factories where they've made enough food to produce a dinner for everybody in the country in the matter of less than a week. You know, these numbers aren't unheard of in industrial applications. It's amazing how much you can produce but that also makes it a very strong target for someone looking to make a sustainability improvement because of the volume. Complex processes, though, can make this very difficult. When you're trying to do design for sustainability, these processes are not just, we do a couple things, we harvest, we cut, we package. You really start to look into it. There are so many steps and so many supporting steps. The complexities is what leads to some of the areas that I'm gonna ask you to look at when you're looking at design for sustainability, because things get lost. Things are out there, there's opportunities out there. People walk by these opportunities and they don't realize that you could design things a little bit different to be more sustainable. And regulations. Around the regulations, there are a lot of rules not to do certain things, but within gaining efficiencies, there's things I just can't put down the drain, there's things I just can't do, but how to be more efficient, that's usually not really the realm of a lot of these regulations. They're relying on the industry to figure that out themselves. So, getting on the same page with if it's internal or if you're working with a customer or something, maybe I'm making a piece of equipment, I've got to find out what their goals are. I threw up, this is typically an eye chart, but these are actually quite big. You might be able to read it. It's not really meant for you to read, but the idea is this is Ecolab sustainability goals. So you see things on there like we're going after reduction of water, we're going after reduction of wasted food, things like that. Those are all things we can impact. The idea here is before you design anything, you gotta get on the same page when you are thinking about sustainability because of that, the broadness of this topic. Also, not just what, but how do we calculate it? I'm on a global team for my company where we have been talking about how do we calculate sustainability for 2 years. It was, I thought, going to be a very easy question to answer. Here's how you calculate energy savings. Done. We can do this in an afternoon. Honestly, it has taken us a couple years to go all around the globe. I'm trying to cover about 170 countries to figure out what do you mean by energy savings from a sustainability? How do you calculate that? So being able to come up with those equations and how to calculate what is true savings, what is not, don't double dip, those kinds of things, that's an important conversation to have if you're really looking to design a sustainable benefit. You're trying to say this design is better than this one. Understand their calculations, understand how you might do it. There are some industry standard calculations that are being adopted a little bit more readily out there. I can provide, I do actually have a few references towards the tail, so you could do a little bit more reading, that's what I call it. But really, whoever you're working with, you gotta understand how do they calculate it, not just what they're interested in, but how do they figure out whether or not they've achieved it. All right, talking a little bit more about sustainability, but I like to talk about a key concept here, that there's some fundamentals. So I'm gonna talk you through this logic path here, where the key concept is, I'm gonna assume safe food is needed by all people. Everybody needs safe food. If we don't have safe food, people get sick, it costs people's health, it costs money, it has very real consequences. So that's where I'm trying to lead you. But we'll start out with unsafe food is waste. So if I have unsafe food, it's a waste of some way. I might be able to recover it, do animal feed in an industry I used to work at. We would downgrade things and things like that, but always it was a waste. So having safe food, if I do anything but safe food, it's a waste. What is a waste for me? Waste is not making the best use of my time or resources. I'm limiting what I could do because I'm producing waste. And then follow that through a little bit further here. Inefficient processes can actually make things more unsafe. We know microorganisms, you give them a chance, you give them enough time, they're gonna grow, right? That's a risk. If I'm being inefficient, I'm letting things kind of sit around, or I'm just not using the best amount of my time, I'm increasing my food safety risk. So if I can make things go faster, smoother, flow through the process, then I am building safer food. And so improving efficiency improves food safety or sustainability. So that's how I'm trying to get people to link where I'm taking out waste, I'm being more efficient, and it's tied to my food safety. So I'm doing both. I'm more sustainable and I'm safer. So one thing about waste that I did find this kind of interesting when I looked at where does municipal waste go when you throw things in the trash. We got all these recyclables or recyclable bins, you got compost bins and stuff like that, but where does it really go? Landfills, still. This is pretty modern where they looked at it. We just pool dirt on top of it, just kind of turn it under, just kind of bury it. That's over 50%. So all that recycling, energy reclamation and everything like that, that's still a very small drop in the bucket. There's still huge opportunities for sustainability where we don't just pile the waste on top of it and put some dirt on it and call it good. Some other things to consider on sustainability is environmental factors. Remember, my definition is I want the future generations to have the same opportunities that I have right now. That's sustainability. So the more I'm going to pump into the environment, the more I change the environment, the harder that's going to be for them. So I consider, especially from the chemistry side of things, because that's what I focus on, I consider biological oxygen demand, all these different factors of what I'm doing. Can I be more efficient on some of these things? Do I really need that low of a pH to do this part of sanitation? Something like that. Maybe I could design it so that I don't have to use those types of methods, or I can use a less severe method. So these are all different things that potentially, even if they do a good job, I'm really fast, I'm efficient, but if I put something down the drain that's not sustainable, I've also got to consider that design. So talking through, okay, sustainability. I modified the sustainability 3 R's a little bit here because an important thing for tying food safety and sustainability or hygienic design or some process design of sustainability is I've got to evaluate what I think would change. Is my design better or not? We have really effective methods on evaluating designs sometimes. There's all these swabs, there's tests that we can do to say one design is better than another. I saw a lot of mentions of checklists for sanitary design. These are all things that you can evaluate before you go through the process of trying to do a sustainable solution and then confirm that evaluation. So I still keep the 3 R's, reduce in the process wherever you can, reuse things in the process where you can, recycle where you can, but make sure you have a plan, evaluate that plan, and then confirm at the end that you're actually delivering. Okay, now that I think we're in a little bit more commonplace on what sustainability is, I want to talk about the path. What is your path? What are some things that you can do to tie sustainability and good sanitary design together? So, sanitary design, simple concept here is if something is easier to clean, for me on the sanitation side, I don't have to be as aggressive. So this is just a simple 4 factors. Whenever I try to clean something, I'm using 4 factors. Mechanical force, concentration, temperature, time. If something is just straight up easier to clean, it's not a rebalance of the pie for me, which is what I normally have to do. I can actually reduce the size of the pie. I can take off time and I don't have to balance it with anything else because it's just easier to clean. So better sanitary design that's easier to clean, I'll show you how each one of these, if I could reduce the concentration, if I could reduce the time or temperature, I'm actually being more sustainable. So get that pie smaller and you'll be more sustainable, but still maintain good food safety. Another target area that you look at when you look for sustainable solutions is the water itself. can I reduce the amount of water? Sometimes there are good trade-offs, and sometimes there are needed trade-offs. If we're using water in dry processing operations, do we really need to do that? There are alternatives. I just saw a great poster out in the hall about dry cleaning with maybe an antimicrobial oil or things like that. There are definitely people working on solutions like that. We're working on some internally on how to use less water or low or no water methods to do some of this sanitation activity so that you can opt out of some of those things. But other ways to reuse, reduce cow water, post rinses. Are you just letting your post rinse go down the drain? Is there an opportunity to grab that post rinse and do some more work with it? Things like that. I got a few other things, but a lot of times water is an essential component for good sanitation because it does so many things for us. But are you really using it as efficiently as you can? That's what I'm really asking here and when I evaluate people's designs for sustainability. Energy. This is something we go through and we do some pretty extensive 3 to 5 day assessments on how people are using their energy. Are there opportunities to save? One of the things we focus here on energy is, even though it's often ignored because sometimes the savings are kind of small, it does add up over time. So knowing that your selection between something that's a little bit more efficient or less efficient, calculate that. Use a calculation, quantify it so that you know what that trade-off is. Yeah, it might sound a little bit more expensive to go with a VFD pump versus maybe a static pump here or there, but if I can throttle that down, if I can perfectly balance a system because of that, yes, I'm using a little bit less energy, but it will add up over time. Maybe or maybe not, we'll pay for the cost of the adjustment, but there are other benefits that if I capture all of those sustainability improvements, then you'll see that it probably will pay for itself. So understanding energy consumption is not something to be ignored. There is usually enough here, especially when you tie it into these sustainability goals and initiatives. It's not just straight profit anymore. People aren't just saying, how can I operate my plant as cheap as possible? There are these other goals too. So relook at your energy consumption, and if it's not just how you're using the energy, or yes or no you're using the energy, but are you using it as efficiently as possible? So when you do have things that increase temperature, operate a pump or something like that, do you know when you need to cut that off? Are they running excessively? We get into so many situations where there's just way past what's needed. They've done some verification work, or maybe they aren't sure where to find verification or validation work. Ask for help. That's where people like me can come in. I can help you find references on what good set points are to get you started. But ignoring it, ignoring the fact that you're running for an extra 10 minutes on every cycle of sanitation or something like that, means you're not keeping up with a sustainable enough solution as you could. So make sure you go back in and reassess those. Use some sort of checklist to know whether or not you are keeping to your program. Sanitation prep, here's something in design that I try to push a little bit, is if I can do things outside of the operations when I get into sanitation, so I can do dry pickups and things like that, I won't see people doing like the thing that just gets me every time is I watch people wash things to a drain or move things with water. Talk about inefficiency. It's usually hot water too. Blows my mind on how much they're wasting, where they could have just picked it up with a shovel or maybe not produced it in the first place, figured out why that waste is being created so that you don't have to deal with it after every sanitation. So first thing I do when I look at someone doing a sanitation is how much do they have to pick up at the beginning? So is the process designed really well that it doesn't create all that waste when it runs? So that's a really easy one to save. If you quantify it, sustainability savings are there. And then how quickly. This is something that surprises people sometimes when I try to find sustainable solutions for them, but you were waiting too long. You let the soils change, and now you have to spend extra time, energy, all those things that I captured from the sustainability standpoint, you've just added to it because you just simply waited too long. You've let the soil or the nature of things change to be harder to remove. So sanitation prep, don't overlook it, even though it doesn't look like you're doing a lot. Get to it right away. Use the most efficient ways to get rid of it. Proactive food safety, being proactive about this stuff. So designs, I've heard a number of cases here where we've talked about designs that we know are bad. If it's a bad design, if it's a bad sanitary design, whether it's infrastructure or whether it's equipment, you are probably also wasting resources that you don't need to waste. Get proactive on it. Go challenge those. Go try to address those so that you're not just addressing it because you know it's a good food safety thing, but you now understand there's ways to quantify that we're actually wasting money. We're wasting energy, we're wasting water, there's money going down the drain, we're not hitting our goals. We say we want to be net zero by whatever date, things like that. You're working against yourself if you're not being proactive in trying to go after those. Then I'll have some specific solutions here. These, if you have a circulated cleaning system, I still see those to this day that are not reusing or recovering in some way some of the solutions. Sometimes good reason, there's allergens and things like that that are special considerations that you have to be very careful if you try to reclaim some of that solution in a circulated cleaning operation, but sometimes they just didn't like the initial price tag of one system versus the other, the complexity, or maybe they just got it it was on sale on eBay, or I don't know how they all end up, but honestly, this is definitely the time to go look at those systems. Are they really delivering today what you need them to deliver? Are they designed to be as efficient as they need to be versus when you installed it 20 plus years ago or something like that? Recovering processed water, there are a lot of opportunities. When we go through, we do these surveys, there's processed water that they generate through the process that just goes straight down the drain. It's like, okay, so we're doing all this effort, we're using all this water that the city or you pull out of a well, but you have a process that's generating a lot of water and you just let that go down the drain. We could utilize it, or maybe it's a warmer water, processed water. I could utilize at least the heat, something here. Those are all sustainable, but they're just wiser choices when I'm trying to create a system that is well balanced, that is as safe as possible, but also sustainable. So look for opportunities to use some of your processed water. Simple one here, VFDs. Not all pumps are VFDs, but when you can, if you have an operation, when you have an opportunity to slow that pump down, to change the speed, to speed it up when you need it, to slow it down when you don't, over time, you will be more sustainable. Vortex breakers. Vortexes and tanks, when you have tanks that are draining and things like that, that time, because you create that vortex, that extra drainage time, it can be pretty significant. If you've ever seen one of these poorly designed tanks drain, it really takes a lot longer. It can almost double the time for draining some of these tanks. So you want to break those vortex or vortices. Break them up, make sure people understand the efficiency of those designs, because it affects how much chemistry I have to put in there to properly clean it. This is an example if you haven't seen one. I used some pictures that Gabe provided and stuff like that, because I think if you don't understand the concept of that vortex getting created in a tank drain, it's a lot easier to just see it, the nice tornado swirl there. Equipment technologies, this is something that is a little bit more modern, but not that modern. Equipment technologies, how to automate, how to know when something is done. rather than just set a timer and forget it, but you can observe, you can watch some of these things. So make sure that if there are technologies that are available for the application, you evaluate those, not just from, does this make it easier for an operator? That's not the question anymore, but could this make it more sustainable, more efficient? Automation in general also is something you gotta look at. Controlling cleaning cycles, you can actually improve food safety and efficiency at the same time with a lot of these automation solutions out there. So consider it. There are other pressures nowadays that are also getting people to look at more automation, difficult getting people to work in some of these roles, things like that. So worthwhile to take a look at the sustainability options of automating some of your solutions. And then remote monitoring. There's even people halfway around the world that will monitor and optimize your CIP systems or efficiencies of some of your operations. Engineering solutions. You're not alone. There are so many engineering firms out there and people that are willing to help you take a look at your design, see if there's opportunities to improve the efficiency of it. Reach out to people like myself, even on a chemical supply side. We'll help you take a look at some of your potential systems that you could improve. Tanker sprays, I think this has been around for a while. So some of these I just included. If you haven't looked at them, please look at them if you're not using some of these types of tools that are readily available, been in the industry for a long time. Cabinet washers, if you use a COP tank that's inefficient, maybe you're overflowing, maybe they're just not managing it well, things like that. Consider, is there a cabinet washer that is that much more efficient at it? Those utilize the water, the chemistry, the heat, all of those things a lot more efficiently than some of the older styles of just a big circulated tank that fills up and drains multiple times. One of my last slides is for more reading. Honestly, this topic is so complex that I really dove into so many of these different sources and thought, man, I really got to share these with you so that you can explore on your own. If this really interests you, go to some of these links. Again, download this from the website, but go to some of these links to see how people are balancing some of these sanitary design sustainability concerns. Because some people think being more sustainable means I have to increase food safety risk, meaning I have to use less chemistry or something like that. It's not true. There are a lot of these resources out there who have gone through and studied that and can say, no, you can actually do the win-win here. And some other ones out there on just understanding how people are setting up their goals and things like that. Just some more reading. And with that, I'm gonna close.
Thank you very much for the time today. I appreciate it. My name is Nik Ocello. I'm the sales director for Laufer Valve Technology. We are Laufer International's subsidiary and master distributor here in the United States. Laufer International was founded in 1996. We do two things really well. We do valves and we do pigging systems. We got our 3A approval for our valves in 97. We passed the EHEDGE Class 1 cleanability test in 2009. And then in 2015, we got 3A approval for our pigging systems, or product recovery systems. So just to kind of lay out where we're coming from. This is the overview. We're going to be talking about, one, what is pigging, product recovery, for those of you who may or may not know. We'll talk about its benefits in relation to CIP, waste and sustainability, ROI, yields, and a little bit about the project management and some of the issues and pitfalls that come up with pigging systems. First off, what is pigging? It's taking a solid projectile, pushing it with air or water, and clearing the product out of a pipeline. So pretty important in liquid process systems. It started in the oil industry, in oil production, where they'd take a bale of hay, wrap it in barbed wire, and shove that through a pipeline in order to scrape the crude that was stuck on it. And that the barbed wire on the steel pipeline would squeal like a pig. So we get pig, pigging. It's kind of apocryphal. I tried to do some research and actually find someone that could prove that that's the case, but they all just talk about this is how it is, and we just know that. So that's what we'll go with. This next slide has a video of us pigging out cooled caramel from a sight glass line. So I'd just like to show you all how effective it can be, especially when implemented correctly. It's gonna look a little funky because, again, it's caramel coming out of a pipeline. And you'll see the split actually from the butterfly valve. That's the outlet. So we are pushing with only like 22 PSI. You can see most of the caramel is getting pushed out of the way by the front of the pig, while the back of the pig is sort of squeegeeing the line clean. We remove over 99% of the product in the line. It leaves behind a thin biofilm. But pigs can be incredibly effective ways to recover your product, clean out a line before you have to CIP. There you can see the caramel still holding its shape too. That's how you know it's not hot. So let's talk about this. If you can get a line that clean, then you don't have to use as much CIP chemicals. You don't have to have as many CIP cycles, depending on what your product is. Because of that, like clearing out allergen inclusions. One of our customers, they make ice cream. They have allergens all throughout their product. Sometimes it'll take 4 CIP cycles, and sometimes it'll take 7 CIP cycles in order to clean out those allergens, test right, so they can make their next product. Imagine, how much time, money, and material is going in to 7 CIP cycles to clear out an allergen. Now, if you can clear out 99% of the product in that line, most of the product in those valves, you've already done sort of your first step of cleaning. Because of that, if you're reducing the amount of CIP cycles and the amount of material you're using, you're also reducing the wear and tear on your CIP loops, all the equipment. You're talking your pumps, your pipes, the weight supports, everything. The wear and tear gets reduced, right? Because, pipes aren't shaking with the pressure and the movement of the product through it. This is a little animation just showing pigging a line, CIPing the line and the valve after. So this is a two-way system with our turning and cleaning stations where the pig can actually get cleaned inside of these stations. So cut off your product pump, get your PLC started to push the pig through. You see as it moves through, pushes most of that product out of the way, there's not a whole lot left over that you have to clean. It's pretty straightforward. This also goes into, and we'll talk about it a little bit later, but being able to automate a system fully without being able to clear out most of that product. Automation gets a little harder, or at least how sure you are that everything is clean really isn't that high. So you could CIP your pig in the system, outside of the product line, and CIP your valves, your pipes, etc. With most of that product gone, again, we're talking about a lot of very direct benefits as far as cleaning goes. So in terms of waste and sustainability, you are reducing the amount of fresh water you have to use in order to flush your pipes. You are literally eliminating product going down the drain. Because what happens if you don't pig? Well, you've got to flush that line, you've got to dump that product, it's gone. You can't use it anymore. And then you have to treat that wastewater before it can go back to the city, right? So there are a number of steps involved in terms of sustainability and waste, where pigging first will help you out a lot. Mixed phases ruining a new batch, so you can separate your phases, push the pig with maybe the next product batch, and actually have a good separation there between your first batch and your second. And then in terms of stability, we're talking about being able to predict your water usage a little bit better, getting it down, obviously, as well as reducing chemical treatments. The ROI for pigging tends to speak for itself. Most of our customers make their money back within about 3 months, if not less. This ROI calculator is something that we have. This is going to be a 4-inch line, about 150 meters, and it costs 80 cents per kilogram. So with that, every time this company pigs, they save $1,000 just back into their pocket. You pig 5 times a day, that's $5,000. You do that over a week, you've paid for your pigging system in a week, depending. Pigging systems are anywhere from $15,000 to $50,000, depending, a good one. There are definitely cheaper ones out on the market too. If you've got clean pipes, you've got pure product, right? You don't have anything mixing in. You can package an entire batch. Leave that for your engineers to figure out the math on that, but it's possible. You don't just have leftover from your tank. Or you can preserve the excess for later. Put it in a tote, put it in a tank or something, reuse it for the next batch, the next day, depending on what the product is. You're also reducing your downtime by lowering the cleaning cycles and the amount of time you have to clean. You're separating your batches by a pig if you want. All of these things are reducing the amount of downtime, increasing uptime, and increasing the yield for that factory. Pigging also helps when you have some of these older plants. What I've been told, right, is a plant is either out in the sticks or in the middle of the city. And a lot of those plants in the middle of the city are old. They are interestingly designed. So you've got points that don't drain. You've got maybe tight bends that don't get that clean. But if you can pig, you can help and clear some of that stuff out. It's also really important in terms of automation. You can automate this sequence, right? But if you're not confident that the piping is clean, that most of that product is gone, then are you really comfortable with automating it? So if you can clear out 99% of the product in the line and then clean, your level of confidence can go up knowing that, yeah, I think we're gonna do a good job here. Now, there are off-the-shelf pigging systems that you can buy. You buy a launcher, you buy a catcher, you buy the pig, and a little hook to pull it out of the pipeline. They're good. They will clear most of the stuff out of the line. They have their own issues and pitfalls. Most of the pigging systems that are going in, they should be customized. The salesperson should be looking at a P&ID to determine what the equipment is and how it's gonna work. You can, like I said, you can buy something off the shelf. It's not too expensive. But if you want something that'll last, that'll work consistently, it really tends to be a custom project. You can see here we've got our pigging system questionnaire, an example of a P&ID, and then on bottom right is our signal list. So again, for the automation, right? You should be working hand in hand with whatever company is selling you a pigging system. There should be some direct involvement, some questions back and forth. We're gonna cover some issues and pitfalls. So the very first thing—
through the 2-inch PVC water grade tubing that's being used at Morehouse, and we're testing it at 1 bar pressure.
There we go. So it is a projectile, right? You gotta be careful. You need to regulate the amount of pressure that's pushing that pig. We have seen other companies, when we go and try and sell a pigging system in, they say, oh, well, we exploded the catcher. How in the Lord's name did you blow up a piece of stainless steel? And well, when they're putting 20 bar worth of pressure behind a projectile, it's gonna go somewhere, right? The next thing that you wanna be mindful about is what kind of pig are you buying? Are you buying one that is over-measured for the pipeline and hard? Or are you buying something that seals dynamically to the inner diameter of the pipeline, something that squishes, something that flares out? That matters, right, because of what we're gonna talk about next: bad welds, dents, other obstacles in that pipeline. I think we know plenty of operators that use percussive maintenance, to get a pipe moving. And you can't guarantee what the welds look like on the inside of a lot of these plants, right? Especially if we're talking about a plant that was built in 1912 in the middle of Kansas City or something, right? The kind of pig you choose matters because when it hits dents, it'll stop. And you hear the rattle as the pressure is building up behind it, and then to the next bad weld or the next dent. Again, right, we're talking about pressure and damage to your support weights, your piping, everything that's shaking with that pressure to build up behind it. Also, you start to slough pigging material into the line. You gotta be careful about that. Replace your pigs often, inspect them. You don't want silicone or whatever it's made out of getting into your customer's product line, or if you are the customer, into your product line. Next thing to think about is your pig that you're gonna buy in the product flow when they're not pigging. Some pigging systems, that's the design. The pig sits in the pipe, it's in a little cage or something, and you flow product past it. Well, if you've got a pig that's sloughing material off, and now it's in the product line constantly, you might just be contaminating your product line. So again, something to keep in mind or something to ask for. Hey, can we make sure that pig is out of the product line until it's actually pigging, right? Unsuitable equipment. So there is certain equipment that you can't pig through. You can't pig through a flow meter that's sticking through the pipeline. You're gonna break the flow meter. Some of these tube heat exchangers, their inner diameter is a little bit smaller, say, than the tube. Again, this is very general, it really depends. Don't put a pig through a pump. It's not gonna work out, right? Certain valves, you can't pig through a single seat valve, right? It's not designed that way. Ball valves can get out of alignment, the ball with the housing, and then you can't pig anymore. We've had clients actually complain about that, and we took advantage of that and sold our stuff in. And then, to me, the most important thing is that if it's a 3A system, and there are certain users who, especially in dairy, need a 3A certified system. Well, look at the certificates for the equipment. Is it CIP or COP? That matters. This is a trick that salespeople will pull on you. They won't tell you that it's COP only. They'll just say, hey, it's 3A, you're good. Well, not everything cleans via CIP, right? We know this. So it is important that if you're going to be putting the system together, you're paying attention to these certifications and actually reading them. Thank you, everybody. I really appreciate it.
Good afternoon, everybody. For 20 years, I was on the end of the oh darn push button. Anytime that there was a microbiological problem, I was the one that had to walk into the napalm fire. Now, I don't know whether you've ever had somebody yell at you for 4 hours straight, telling you that all your stuff was wrong and then ask you to help them. Not a real fun. But in traveling, you kind of get out to the point where you see things that I always call the devil in the details, if that makes sense. It's all that granular level stuff. So once again, traveling in an airport, I kind of looked at this and I went, that doesn't look very good. Looked at it a little closer. It didn't even look even much better. It was a pretty gross growth on a table where people are actually eating. So, devil's in the details. Here's another one. Anybody want to take a guess where these two drinking fountains were at? Hospital drinking fountains. They had cut back on their cleaning staff, so they were only cleaning the drinking fountains once every 4 days. I really want to drink that water. The goal of this talk is to talk about how do you select a vendor. I mean, you look at it, there's a lot of different people out there, and there's a lot of different methodologies to go after this. It's really, you got to be comfortable with the people that you're going to have either build something for you or repair something for you or change something for you. Now, I'll go into a couple more granular details as we go, but it's really that's important. And I always tell people, no matter what you're doing in the food processing industry, you always follow the water, because the water never lies. It will always tell you where it's going, no matter where it's coming from. All you got to do is follow it. You know, every good project or every good operation starts out with a good process description. Everybody know what a process description is? That is somebody telling you how to do your business better than what you know how to do it, right? Kind of, sort of, you're laughing your head going, yeah, kind of. Well, in essence, you know, a lot of times they do have very talented people that are going to look at it and say, yeah, this is what we need to do. This is part of what we need to do and part of this process, okay? But you really need to have a good, solid process description. Now, where I look at it when I say good, solid process description, I look at it and say, okay, it needs to include a lot of things. You know, and as I'm getting older, I like to see more granular detail because I get pulled into a lot, rightfully so, because I've been around and doing this for a long time, to be that advocate of CIP and process design. Because my background is both in process engineering and in food science, and doing this for 45 years. So you learn after time, you learn what you're looking at over that period of time. So process description includes a lot of things. You know, a functional description of the process, a well-defined description of each portion of the process, and those components that lie within that process. Then I think it's pretty important. If it's going to be a major process change, then you should have P&ID drawings that support what you're trying to complete, and then actually highlighted line drawings of what the proposed process changes are going to be, and then what they look like in the afterwards. What's the as-built going to look like? Because everybody always forgets. Now, I can see a show at Bobbleheads if you want to. You get all this documentation up front, but it's very hard a lot of times to get the as-builts, to get the closeout stuff, to get all the documents that have all the proper line drawings, get all the highlighted line drawings and the pinning charts and all that for all the CIP systems, so you know exactly what's in there today. And the other one is whether it has mixed-proof valves or anything like that. How do you know that they were tested correctly? The reason I threw that one on there is I just went through a startup with a client, and I asked him, I said, well, how did you check? You know, they had a whole lot of mixed-proof valves. I mean, they had over 1,500 mixed-proof valves. So a lot of them, right? Now, so I asked him, how did you verify that all the mixed-proof valves functioned at the startup? And they said, oh, well, we sat in the control room and we toggled them and we watched the limit switches make the limit switches. Okay. So what was wrong with that problem? Or what was wrong with that situation? They didn't look at the valve. I mean, because if you, just because, it's just like kids. I mean, how many of you have kids? Just because you tell your child to do something, that does not mean that necessarily they are going to do it. Or they're not going to do it to satisfaction. That's the other side of it. But in that same regard, you know, and I asked him, I said, well, when you did all these checkouts, you know, these 1,500 valves, I said, what was your fail rate? He said, we only had 10% fail rate off the start. And I went, 10%? I said, that's 150 valves that didn't work. That should be of a concern, right? Said, so where's the documentation? This, you know, because I'm like a rabbit hole kind of guy. Like you could tell, I might get that way. So I kept digging, you know, it's like that piece of paper thing. I'll keep digging the paper, you know. Okay, peel that layer of lettuce back. Let's get down to the next one. All right, well, where's the documentation that you did that said you did these tests, that you did this, that you did that? Oh, it's over here on this spreadsheet. Where? Can I see it? Well, we'll have to print it out for you. Okay, I'll wait. How long, do you think I got that in any? No. Because do you know why? Because it didn't exist. What they were doing is taking a PID drawing and just writing a check mark on the PID drawing and not doing it against an actually list of the configured products. Why is this all important? Next 20 years, how many of you are going to retire? Next 20 minutes, how many do you want to retire? Next 20 seconds? No. It's all about legacy. it's being able to hand over that treasure trove of information. And, if it's done right, it's easier to hand it over because, when you look at a corrective action thing, that tribal knowledge thing, does anybody agree with me on the fact that tribal knowledge is kind of going bye-bye? Show of hands. That's scary, isn't it? That's like 3/4 of the room just went, Yeah, that's pretty scary. Because that's kind of the legacy of where we're going, is that tribal knowledge is going away. What's in that tribal knowledge? It's how to figure out a lot of those problems that you don't really have the answer to. It's being those people that have been able to do it. People are readily changing over positions, so you need document stability. I mean, that's the thing. You need something that's going to be locked down as a document that says, okay, no matter what, this was checked out at one time, and it was good. So that at least as things are changed, that the documents that follow along with that process. Do we have that today? Do we have that today? No, in a lot of places. Some do, some don't. Mass balance is no. When you look at the current state, when I look at it as a supplier reality check, and I had to do this because I had a lot of friends of mine that were process engineers, engineering managers, and things like that. So they would grab me and get me involved with these, which is a lot of times no fun. And I'll explain the whole reason why later. Everyone says they are a CIP and process expert. Why wouldn't they? What do they want? They want your business. Well, I'm the best CIP guy there is in the world. Am I? Technically, I am one of the top 5 in the country, but, I wouldn't pat myself on the back. I'm too old, and I'd probably dislocate my shoulder, and I wouldn't be able to golf this summer, so I won't do that. But I was taught by the guy who invented CIP, so I got a pretty good lineage behind me. So, and I still learn something new every day. Some of the things that I could share with you just would blow your mind that I've found over the years. But they want your business, so why wouldn't they tell you that they know everything that there is to know? The number of true CIP experts is declining. I'm going to retire in a few years. There's a lot of the other guys that I know and ladies, there are some real good ladies that are CIP expert, are going to retire in a few years, and they're going to be gone. So what do you do then? There's a big gap there. Then following up next, the complexity of the systems are increasing exponentially on a daily basis. The mix-proof valves going into play. How many people know what mix-proof valves are? Okay. Now, keep your hand up if you know what they are. Now, for those of you that have your hand up, how many of you really, really know how they work? Okay, that's pretty good. Because most people go, I know what they are, not quite sure how they work, because they're kind of a mystery in a box. Those mix-proof valves, they're designed to make things easier, but can they make things worse? Oh yeah. Because you get into this whole, it's a vicious cycle. PLC programmers, what are they good at? Writing code. They're good at X's and O's. They're good at putting stuff in. But who are they being told to do stuff by? Process engineers. All right? So what if the process engineer got dumped on by a senior process engineer and said, this is your project to do, and oh, by the way, if you fail, you're fired. So what happens? It's like, So they give it to the PLC guys. The PLC guys go, let me see, is it going to be him or me? Him or me? Him or her or me? So they're just doing what they're told. So they have plausible deniability. They're going to do what they're told, even if it's wrong. So here's a good example. I had a plant that had a lot of mixed-brew valves, and they had a valve cluster. It was part of a line circuit. There was 8 mixed-brew valves in a row, okay? Now, mind you, this was about 200 feet away from the CIP system, and they thought it was okay that they could do an upper seat lift on all 8 valves at the same time. Anybody here want to tell me what happened when they tried to do 8 upper seat lifts on a mixed-brew valve that was 200 feet away from the CIP system? How many of them got flushed? Rationale says, hey, I pulse those valves. It's okay, I'm going to do it. and they didn't have eyes on it, so they didn't know. They didn't know that they didn't have any solution coming out of those valves. So case in point, what happens over time? So getting back to that when you're looking at an integrator, when you're looking at selecting somebody to do that job for you, that's one of those questions that you ask. You say, okay, we're going to put a lot of mixed-proof valves in here. I said, how do you handle pulsing on mixed-proof valves? That'll be a stopper in a heartbeat, because makes them, where'd they get that one from? And they'll go, damn, Rector's at it again. Most integrators want to get in and out as fast as they can. Why? Dwell time is money. So they want to, what's funny, and I hate to be cynical, and it's not everybody, and I'm not trying to buttonhole everybody into one thing. But when I look at a piece of PLC code and it says John's Dairy, and they're working at a plant that's actually Amos's Dairy, something's wrong. The descriptions match to somebody else's plant. You know what's happened. There's been a lot of C&P, copy and paste, that's taken on. So it's just those little questions. And it can happen, but make sure you clean up after yourself. Recruiting people that want to invest full time to understand truly about CIP. When I joined the Zee Company, and this was kind of unheard of, one of the things that because I had to meet with the owner of the company, it's a privately held company, I had to meet with him, and he's not an easy guy to talk with. Smart guy, built a business from the ground up, super guy. But he said, what do you want to do? And I said, well, I want you to devote 25% of my time to mentoring. And this is a sales-based organization, mind you. He said, I want you to devote 25% of my time to mentoring our associates. You think that was a tough sell? Now, mind you, this guy has built this business from the ground up, so he realizes how important it is to build the business and do it right. So what do you think his response was? 25%, you got it. Whatever he said this, because he realized the importance of being able to mentor younger people that were interested to come in and fill that gap. To be able to come in, because there's a lot up here. I've seen a lot of things, and I've had to fix a lot of things in 40 years. I want to be able to share that. I want to be able to help other people understand those tricks. We've been into those trenches, and you've been able to dig and dig and dig and find out what the root cause is for problems or opportunities, if you want to call them that. But to be able to devote that kind of time is pretty unheard of. So I'm pretty proud of him. Taking all that into current state, where does that put us in the future? I'm a little concerned myself. The devil's always in the details. So here's an HDST, end of run chart, and a CIP chart. Can anybody tell me what's wrong with this one? There's a caustic wash, an acid wash. For anybody that knows what an HDST is, these are the flow diversion valve pulsings. Okay, if you know what an HDST is, if you're in diverted flow, how much of an HDST are you missing? More than half of it. How much of the cleaning are you missing? More than half. So how often are we in diverted flow? Way too frequently. According to the PMO, who has control over flow diversion valves and leak detect valves during CIP? It's not in the PMO, it's up to the processor. So you can do anything you want to with them. So you've heard, because you look at this big picture. We probably all heard about the story about the old guy with the small hammer who charged that really huge bill to come in and fix something. They got a $10,000 bill, and they balked at it, and they said, why was this $10,000 bill? Said, well, it was $5 for the hammer. It was $9,995 to know where to hit it. So it's just that same thing. It's using that experience to come across. Process design reviews. Who needs to be on the teams? I really think that there's a large group, and really if you're smart, you do bring in some outside technical people too, because it's not only good just to have internal people, it's good to have external people or external experts that could come in to have an objective view of what's going on as far as operations. Now, here is a process design review. This was a thermal process system This is the discharge line out of the product. It comes out here. Now this valve right here, obviously is a mixed-proof valve. This actually carries the product out of the system. So if they're going forward, that's the way it's going. But we're not going to care about that right now. In the first position that you're looking at, you have the process discharge. If you follow the green line, the product is coming out, it's hitting that valve, it's going out, and it's going where? It goes back, it's a balance tank. So it's going to the balance tank. So we're going to go to the second position. So the second position is also coming out of that line. We're coming out, we're coming up, we're coming through this line, we're coming across that valve. We hit this valve, and this one also goes to where? Goes to the balance tank. Now, position number 3. We're coming out of the process. We're going up through this valve again. We're coming down through here. This valve is shifted. Now we're going here, and we're going to the balance tank. From the discharge, we have what? We have 3 routes, and where do they all go? What are we missing? Missing the drain valve. Long story short, on the initial process design review, there was a drain valve. There was 2 of these process systems side by side. There was a drain valve. Somebody went through them, they redid the drawings, they took the 2 drain valves off. Those drawings went to full production, they went to the plant, they got into the plant, they had no route to get these 2 process systems to drain. Problem or opportunity? So here's where I actually have a beautiful, just so you guys know, I have a beautiful framed letter from an engineering firm in my office at my house, because the guy was the engineering manager for this company, came to me and said, well, you don't know what you're talking about. You're only just a simple process engineer. He said, I'm a PE. He said, you're wrong. I said, okay. So we had a little argument back and forth. I took pictures of where there was missing the drain valves. And then I told him, I said, sir, I said, I don't care if you have PE or whatever you have after your name, but I would like the apology letter in email tonight before you leave for work. And then tomorrow I would like the copy on your letterhead with your live signature on it and your PE stamp on it, email or sent to my house overnight, delivery for before noon delivery. Guess what I had at my house the next morning? And it's so proudly displayed in my office. Somebody did not double check the drawings, and those drawings, those process drawings went directly to the installers, and they said, hey, I installed what was on the drawings. So we wondered why we had an extra 2 valves, because they ordered the valves, so they didn't know why they had them. How many of you dealt with pharmaceutical? So PQ, IQ, OQ. I really think that my personal opinion, needs to take a step more into the dairy industry, especially into the aseptic side of things, because that really puts that layer of intensity to each one of the steps of the process. And that's where none of these steps are easy, but if you look at DQ is when you take a look at those design qualifications, making sure everything is on there that you need based on the process description. Then you go to installation, the IQ, that you look and say, okay, is there proof that the equipment can do what it needs to do? Then operational qualifications, that's that stuff when you're doing the seat lifts and the valve checks and all that to make sure that it's going to do what it's intended to do. And then the performance qualification. And how many people want to do performance qualifications on a clean system? Have you ever seen that? They say, I want to do my PQ or performance qualifications on a clean system. And they say, okay, if I do my 3 back-to-back cleanings, I'm good, right? But it's a clean system. Said, so 3 times clean is clean, so you shouldn't have any problems. You know, CIP is basic. You know, you're pumping water. It's a very simple process. You know, I can't tell you how many times I've been involved with these that it just staggers my mind sometimes how people try to make it complicated. They try to make it complicated so nobody can figure it out. You know, pinning charts. You know, 9 times out of 10, if I walk into a factory and say, Has your integrator provided you with pinning charts? What's the look that I get? Yeah, probably 50% of the time they say, oh, we got them, but they're what? Outdated, and they're probably not accurate. So what are they worth? Probably, yeah, because you don't know what's been changed. And then some of them try these little things, they call them op codes or something like that. It's just, I call it foo-foo dust. They try to hide stuff in there that say, oh, you don't know what you're doing. You don't know how to make it program because we're going to hide this thing behind a code that you don't understand. Well, sorry, there's a lot of us that know how to do it and we can understand it. Optimizing during validation, it's kind of a novel idea. I've done a lot of work with a lot of clients saying, okay, just because you're putting a new piece of equipment in, why don't you kind of try to optimize it at the same time? Rick was up here talking about sustainability and things like that. I can't tell you how many times, and I think Gabe, you'd probably agree with me, when you look at CIP programs that get put in initially into processes, that are direct copies of each other. So you got silo 1 equals silo 2 equals silo 3 equals silo 4, and they may be apart from each other, but they'll still have the same exact program in them. Are they the same? No, they could have some subtle differences to them. So it's good to have a standard of identity of their own, but it's also good to be able to do it, if you can, optimize it a little bit when you're doing it. But you got to have somebody there that can help you through that process, that understands how to do the optimization. Because I've seen it go too far. 2 weeks ago is in one where they actually over-optimized. You know what over-optimizing gets you? Gets you into trouble is what it does. It's a good example of a silo wash where they weren't rinsing all the chemical out of it before they started into the sanitizing step. So anybody have any idea what happened when those two joyous chemicals were coming together? It wasn't too bad because it was just enough that it got the chlorine out of it, but what happened is the alkalinity, the pH was still there, the chlorine was kind of gone, the pH was still there, and it just took the sanitizer they put in there and just rendered it useless. I mean, so any of the sanitizer was in there was just gone. It was just had no value. Somebody had sold them a bill of goods saying, hey, I'm going to be sustainable. I can drop back your times and I can save you water. Do you know what and I asked the plant manager, I said, well, do you want to save water or do you want to sanitize properly? What do you think his response was? He says, Rick, will you fix it, please? And I said, yes, sir. So out I went and fixed it. So it's doing it the right way, doing the right thing. This is an example of what this one was, and then looking at load factors on CIPs. I try to tell people it's not just, if you have an existing process and you're adding to it, take a good look at what you're doing now. Don't give me a CIP that's only got 2 cycles on it and say, oh, I'm going to optimize that one, I'm going to save the world. Look at the one that's got 20 circuits on it that bogs you down every night. I'm going to show you one that was actually crazy. This one here, this one had an extra 20 minutes of rinse every night they ran it, and it was at 120 degrees Fahrenheit water. And I can't tell you how many years this program was in place, but I ran some rough numbers on it, and the plant manager didn't want to hear it because it was a staggering amount of water. But nobody had looked at it. Color coding, I can't tell you how important this is. First of all, the P&ID drawings have to be right, but color coding is a big thing because the people that come in after you need to know where things are. It's difficult enough to show them an HTST and ask them where it goes in and where it comes out, because that's difficult. Now, you tell them to start tracing piping, it gets even worse. This one was a good one. 16 million gallons of water a year savings on a 3-inch line circuit. Do you think they were happy? Guess how long it took to fix it? 10 minutes. 16 million gallons of water. It was in a yogurt plant. They were starting to pulse the valves immediately. And what was happening is it kept pushing yogurt in all different directions. So it never really could rinse all the yogurt out. Nobody ever thought about it. So instead of pushing all the yogurt out for the rinse, they started pulsing valves immediately. So they ended up with yogurt in their wash solution, which is really a kind of a pretty nice thing. But in order to really get going, they had to triple, quadruple their rinses to get all of it out, to get all the yogurt to come out of their process. So you can see how things can kind of steamroll into an issue over time. They were pretty happy. Plus, it was a capacity-constrained plant. The time that they saved, the water was nothing compared to what they gained in increased productivity. It was nothing. It was millions of dollars in increased productivity. So it does have an additional caveat to it. You always got to ask people where their pain is. You know, at least I do. There's just one way that I do it is I do a pain or a gap analysis and say, or I'll do a FMEA, you know, failure mode effect analysis, and say, hey, where's your pain at? What are your food safety issues? I'll be around later on, so if you guys got any questions, I really appreciate it.
Thank you, everybody. When I saw in the program that I was after Rick Rector, I had to change my presentation completely because I was going to talk about the many things that he touched on. And the only thing that he didn't touch is that when you do a CIP validation, you have to do it at least twice. Once when your equipment is new, and once every year, or at least the first year after production, when the equipment has gone through a lot of wear and tear, and you see the things that could go wrong have already gone wrong. Before we start, I'm going to make a shameless plug. I published last year, with the help of Dr. Jairus Davis, the Handbook of Aseptic Processing and Packaging. And like Rick said, we try to compile a lot of the lost or about to be lost tribal knowledge. We have people from the industry helping us. We had a lot of excellent guys that have been in the business for a long time, writing chapters on it. So, we all know that we want to make safe products. I will not touch in any of the equipment design because you are the expert on that. You have all the 3A qualifications, all the head. So equipment is a given. We know that sanitation has been ensured thanks to Rick and everybody doing sanitation, the Ecolab guys, Rick Rector, and everybody working on CIP. And I want to focus a little bit more on how we design the facility, as it also plays an important role. And finally, touch a little bit on the food safety culture. This is the topic that I'm very passionate about. And at the moment, I'm trying to get a course at North Carolina State that will be called the Psychology of Food Safety. Because all of you have worked in the factory. How many of you have been on a third shift? What happens in third shift? So we know that everything that goes wrong happens in third shift. And in the last few years, I have seen a very interesting change in food safety culture. And that is the use of captive shoes and captive clothes. And I have noticed that people come out of the field. They have been working with the cows, with the horses. They get out of their trucks and go straight into the factory with the same shoes. If they are forced to change shoes before entering the campus, and then they have another shoe to get into the factory, it's like a switch flips in their head. And they start getting into what I call food safety mode. And I would really like to investigate a little bit more what is the psychology of that? How does that affect people? Because that's a very interesting part of the food safety culture. As we put in one of the factories, change your clothes to change your mind, because you're now need to go into the food safety mindset. Everybody knows food safety is non-negotiable. Any mistake we make is going to end up in Twitter, Instagram, TikTok, wherever, with 1,000 people complaining that I got an upset stomach. And even if it's not your fault, they will blame it on you. And that power of the echo chamber in social media is incredibly high. Everybody applies food safety, right? Scientific principles that minimize the risk of contamination or eliminate it somehow, and help us inactivate pathogenic microorganisms, prevent the formation of toxins, and maintain a wholesome product. So now we go into the 21st century. What is that with all these allergens? What is it with chemicals? How do we control foreign materials? And then we go one step forward. Everybody wants everything to be all natural. Everybody wants everything to be GMO-free. And furthermore, everybody wants everything to be sustainable. How do we combine all those things to do a food safety? It's a very challenging landscape at this moment. Nothing is a straight line. It's like going through one of those alpine passes. Besides that, and as we all saw during COVID, we have the supply chain problems. We have the challenge of globalization. We need to bring stuff from all over the world to feed our factories. We have a very complex and fragile supply chain. And our consumers are demanding new things all the time. The batches that we make are becoming smaller and smaller. The changeover times have to become smaller and smaller for us to be productive. And we're always finding new hazards. Sesame was just declared an allergen. Probably celeriac or celery is going to be declared an allergen in the near future. We have a population that's aging. A lot of challenges come with that. And the demographics of the country are changing. That requires different products and will also bring a lot of new challenges. And many of us that have been in an FDA or USDA swapathon know very well that improved epidemiology, DNA testing, will tell them and tell us exactly what the microorganism is in the factory, what the microorganism that was found in the person, and if they match. And that used to take months. Now I think it takes only a few hours. We talked about that earlier, the beauty of the preventive controls, making a risk-based assessment of what could happen in our product lines. How do we prepare for food safety and prevent what's going to happen based on the risk? Be more proactive. And at the same time, we know that any preventive control, or HACCP or CCP, which at the moment they're conflating into the same, needs to be validated and verified at all times. It may be good on paper, but if it doesn't work, it's completely worthless. And in that sense, engineering the facility, operations, and production of the line allow us to decrease the risk and make the production safer. In other words, make our jobs easier. But that requires a lot of work in the front end. As we know very well, when we talk about FSMA, we talk about the food safety plan. And what I like about this one is that it has taken all the elements that used to be only in the CCP, which is the yellow, only production, and has put everything into one basket that allows us to be more complete. Plus, we have now to take into account supply chain, verify our suppliers, verify the stuff that's coming from outside, verify our transport, and the design and construction of facilities, in a way that we are going to be future-proofing. All of us are aware of the issues we had last year with baby formula. So with those two things in mind, what is going to happen with regulation and with the regulatory bodies at the moment is unknown. But I believe those two events are going to be like the Jack in the Box was for the meat industry 40 years ago, because many things failed that were preventable. When we engineer for food safety, we think about all those things at once in a box. We design the plant in order to future-proof it and to build the food safety into it. And I'm not talking only about how the plant looks, the fact that we have to mow the grass, to put things outside, that it's going to look pretty. But also, how do we lay out the lines? How do we ensure that the traffic of people and the traffic of materials are not going to cross-contaminate one line to the other? And how do we control the flow of air? At this moment, in this day and age, and after hearing all your talks, air has to be an ingredient. Because air is everywhere, it touches everything, and a lot of bad things go airborne. So we have to treat it almost like an ingredient. And finally, control and automation. The problems with personnel has been mentioned, and HR is sometimes our best friend, because when we make something foolproof, they hire a better fool. So the more we control and automate things, the better we are. And as all of you know, we need to abide by the 10-90 rule, which is that during the initial 10% of the design process, 90% of the design decisions are made. The more resources and the more commitment we have from management in the front end, the easier the rest of the project is going to go. When we have to comply with regulations and risk-based preventive controls, we also need to be aware that our plant is going to be there for 20, 25, 30 years, 40 years, I don't know. A couple of years ago, I went into a plant in New Jersey that had been built before World War II. Many of the machines were from before World War II, and they still worked. So that means whoever built that one is probably already dead, yet his plant is there. And we all have to deal with that. So we need to be aware that we need to build that for the future. And right now we have many changes in technology. We have to kind of see what's going to happen. People in World War II were not aware of all the changes until now. We probably have a better grasp. We know we're not going to have flying cars. All the Jetsons were a lie, but we know what's going to happen in the future. And we need to be aware that sanitation is still the main source of risk control. And we need to lay out the lines so that they can be optimized in the future and that we can keep that optimizing all the time. When you lay out a factory, you know for sure that it's going to change within 20 years. If the factory changes ownership, new lines are going to be placed. Or the owner is going to get enamored with the type of filler, and it's going to be your job to put that filler there and all the pixie dust that comes around it. It's like magic, right? When we do a layout of a factory, we spend a lot of time figuring out how the material storage, handling, and flow is going to go through the facility. We are now a lot more aware, and luckily we have a few simulation tools that allow us to do this very rapidly. So we can separate the storage from incoming and outgoing in the two sides of the factory. Figure out how we're going to do the transport inside the factory and receiving and shipping. By using the same simulation tools, we can start segregating spaces, segregating flows, making sure that there is no chance of cross-contamination between production lines and between raw and cooked product. And finally, the step that I was talking about, how do we manage airborne contamination? How do we prevent contamination from going to the dirty side to the clean side? And even more, how do we maintain areas that are critical, let's say low allergen areas, separated from high allergen areas or normal areas, even in the same factory? We all have seen these materials and airflow diagrams. We always make them before we start a project. We create what we call the high hygiene or high care, which could be an allergen zone. Then do all the air pressurization so that it goes out of there. Then we go into medium hygiene and to basic hygiene. Meanwhile, we're going to have the personnel coming also through exclusives or through airlocks from one to the other, changing clothes, and trying to keep microbial out of the area. This is much easier said than done, but I wanted to put that one out there. And when we make a plan like this, it's very hard for us to foresee what's going to happen next, what will happen in the next 10 or 15 years. But we try to figure that one out so that when a new line comes in, the principles will be maintained. And of course, the movement of personnel and how they walk around. And in that personal movement is involved what I was telling you, all the psychology of food safety, changing clothes or changing shoes when you go from the medium to the high care. And the part that is paramount, and it's always one of the things that we're seeing, is that we have so much turnover of personnel that we cannot do trainings once every year. We have to start making them every quarter, or even sometimes every month, because we need to keep them on their toes. Complacency leads to contamination. And that has become a very big expense in many of the factories that we work in. When we go now into change and expansion, because new products or new processes, new technologies, we need to ensure that all the principles I showed you before are maintained. And among those, we need to maintain a change control record. We need to make sure that whatever we change in the system will maintain the safety of the product. And also, when we scale up a project, we're going to need a lot of engineering. It's not an easy task. As we were saying, control and engineering, we need to document everything we do. If it's not documented, it didn't happen. It cannot be defended in the court of law. So basically, if you didn't document anything, you're liable for whatever happened. And in this day and age, we need to be ready to start doing electronic records. That is a challenge that we need to be aware of, and we need to start moving towards that. And we need to start working into optimizing the control systems, because factories are very data rich. We have hundreds of thermocouples in the factory. We have hundreds of pressure sensors. But what are we doing with that information? Are we only using the critical ones? What about the rest? What do we do with them? Are we training our factory to be more efficient with those? And that needs to be part of what we call adaptive food control systems, in which we adapt how the factory is running depending on how we see some valves operating. And that can only be done with the use of simulation and statistical analysis. This is a very classic example, a very small plant that was making vegetable dairy products, or plant-based milk, as we call it nowadays. And we were always having issues with fouling that we couldn't figure out. By the time we were detecting the fouling by the pressure drop in the HTST, it was too late. The system was fouled. And we started working using neural networks, and we figured out that the valve, the steam valve, that was supplying steam to the HTST, we were seeing that it was opening more and more and more and more as the system was getting fouled. So we used this one as our indicator. When it opened more than 30%, we went into an aseptic cleaning, into an intermediate cleaning, and that allowed us to extend the run times for a few more minutes. And at the end of the day, that ended up with extension of run times from 8 hours to 16, which is a big savings at the end of the year. But that is not, again, that is not an easy task, and that is something that we need to do very purposefully and using all the information we have. Finally, I'll talk a little bit about validation. Rick touched on it, but I want to go a little bit more about that. Validation of a system is confirming that the system is doing what we want it to do. And verifications means that the system is still doing what we want it to do over time. And according to the CFR, to the Code of Federal Regulations, when we cannot fully verify by inspection and test that the process is validated, we need to validate with a higher degree of assurance. In the dairy industry, this is not common, but in the aseptic world where I move, we have to put micro loads in products, micro loads into many parts of the system, and validate that the system is eliminating those microbes or preventing the ingress of them. But validation is not a one-time activity. It's not something we do during qualification. Validation is not just one final verification step. Validation is a continuum. Validation starts when we design, that will be the design qualification, and ends when we decommission a line. During all that time, we have to make sure that the line is in a validated state. And by validated state, I mean in a state that will be doing what we want it to do. So all through the life of the equipment. Even during the routine of production, we need to monitor the trends to make sure that we're still validated. When we go and change the gaskets, we need to make sure that those gaskets perform the same as the gaskets that we had before. When we change the temperature sensors, we need to make sure that it's either a like for like or is an equivalent change. And that change control maintains the system validated. And if we make more changes, we probably will have to go into continuous validation. Thank you.